some function pointers and some pointers to pointers. Make sure we got that concept down. We'll do a couple tries and catches, see if we can catch some errors that we got. And then we'll jump into this calculator, which they give you in pieces and never really put it all together. So we're going to put it all together tonight so we can see it that way. Hopefully it makes a little bit more sense. So again, I'm just going to open up a new project. I'll call it Chapter 6. Chapter 6 example. And just to get a console project. Keep it easy. Next, get rid of all that other junk. And just give them an empty project. We'll start from scratch. Then I'll wait for the super fast computer to build those two files. Once it's done there, Solution Explorer, source files, add, make a new item, grab a CPP file, and I'll call this function pointers, just to have a name for it. I'll hit add on there, call it whatever you like. So the concept behind function pointers is if I can point to anything in memory, I can point to integers, I can point to doubles, I can point to characters. Well, why couldn't I point to a function or a class or anything more grandiose? So in this chapter, they wanted to show you what a function pointer looked like. So I'm going to create a couple functions that are going to be pretty simple. We'll make kind of the ones they had in the book. We'll do a sum, difference, product, and division. So I'm going to make a couple functions real quick. So in this case, we'll do a double, and we'll call it a sum. It's going to accept two doubles and return the sum of those doubles. So there's let me see if I can make that bigger so you can see it. Hopefully better there. So there we go. We got a function definition. We've got a return type. We've got the identifier of the function. We've got its parameter list. Because this function does not modify the variables, I pass them in by reference and made them constant. That way we save a little bit of time on memory there. We're not making copies. We're giving the actual one. And to find the sum, I just take 1 plus 2, add them together, and return that, and then I get the result. Well, if I take that same concept, I can do the same thing for difference, product, and division. So I'm going to do a copy and paste. And I'm going to call this one product. And to find the product of two guys, I just multiply them together. If I take that same concept, I can do a difference. And I can take the difference of those two. In this case, order matters. And of course, the last one, division. In this case, order really matters. And that'll be 1 divided by 2. So there's us 4 functions. Now, as you can see, these functions all have the same function signature. They both have 2 values that they take as parameters, and they all have the same return type. So because they have the same function signature, we can actually use pointers to point to them. So I'm going to come down here and I'm going to do a int main. We'll fire up the main guy. Return 0. So now I've got those 4 functions at the top. And if I wanted to have a function pointer to an integer, per se, integer a, initialize to be 2. If I wanted to have a pointer to that, I declare an integer pointer. And this is a pointer to an int. And that equals the address of A. That's how I would declare a pointer for a regular variable. Well, I'd like to have a pointer to a function. So just like that, if I want to point to an integer, I do an asterisk before what I want to point to. The same kind of thing happens with my pointer to a function. But I need to describe everything it points to. So now I'm going to define the return type. It's a double. And then I'm going to do my parentheses with an asterisk, and this will be pointer to a function. And then that pointer takes two parameters. And now I've declared a function pointer. So now this function pointer can point to something. What's it currently point to right now? Nothing. Just an address in memory that's probably garbage. So of course, anytime I use something, I want to declare it and then initialize it. So let's say first, let's have it equal to sum. You think, man, that looks really weird. Well, I just took this function pointer and pointed it to a function, and it has to have this same signature or it's going to give us an error back. So let me go ahead and declare a couple of variables here. Double first, give that 4.3, and second, give that some other number. So now we've declared two doubles on the same line using the comma operator. We've declared them using the function syntax by using parentheses instead of equal signs. So now if I wanted to actually use pfunc, I could do that and just do pfunc first, second. And now that would sum those numbers up. So if I wanted to print that out, I'm going to come up here and do an include statement. Well, what am I going to include? IOStream. And then in here, I'm going to say stdcout. Sum is pfunc. I'm going to keep that on the same line. I'm going to hit the enter key. That way it stays so we can see it. So there's a result there. So I got sum is pfunc first comma second. That should work for us. I don't have any squiggly lines, so that's a good sign. Go to debug, hit build. It tells me it likes it so far. Go to start without debugging, and I got sum is 11. If I do some quick little visual there, 7 plus 3 gives me 10, carry the 1, 6 plus 4 plus 1 gives me 11. So that makes sense. Okay, it's working. I'm actually getting a sum. So now I can change what that guy points to. Pfunc equals difference. So now using the same function call there, I'm just going to copy lines 25 and 26. And now I'm going to write difference. But again, I've got the same function call. Put that on the next line so we can see it. I've got the same function call just like I had before, except now my function points to a different function. So now I would suspect I would get 4.3 minus 6.7. Hopefully I get a negative number. Debug, start without debugging. It builds it, and I get now the difference is 2.4. Alright, so that makes sense. That's what we'd expect. And again, I can do the exact same thing again if I want to go to a different function. Pfunc equals product. And again, if I did a cut and paste, so again, I can have the same statement, pfunc first, second, but now I can change what it does because that's a pointer, and I can just modify where that pointer points to. So I can change that guy around. Now, in theory, I could also have an array of pointers. I could set this up to where I save all of those in one. Well, what would that look like? Well, just like up there on line 22, I declare double star pfunc. Let's try that one more time. Double star pfunc2. But now I'm going to make it be an array. Constant double and, constant double and. So there, now I've got an array of pointers to functions that all have this signature. And just like I did above, if I want to do the same thing, pfunc2 index 0 equals sum, pfunc2 1 equals product, and pfunc2 1 or 2 equals difference. So now there's a way we can keep an array of pointers to functions. So now I'm going to come up here and show you what it can't look like. So now if I go back to the top and I change that last division I did, instead of taking an integer or a double, let's take an integer. So now I've just modified one of the parameters to be an integer. Now if I come to the bottom and try to assign those, it should give me a problem. Now there, I get a little red squiggle line, which means I have a problem there. If I go to try to build it, it should give me a good error. And it should tell me, hey, I'm expecting to get a double pointer with two doubles. What you gave me was a double pointer with a double and an integer. Those don't match. I don't know how to put those two things together. So as long as the function signatures match, we would be able to do that. And because they don't, I get that error. So that is a no-go. Comment it out, and now everything's better. So there's a quick rundown on function pointers. Questions there? So hopefully that makes the stuff they did in the book a little more clear. They just kind of talked about it and hoped that you got it. So there's a straightforward example of doing both of those. And if I wanted to be even more inventive, I could do an array of pointers. I could keep that concept going. Now, what's the difference between an array and a pointer? Not much, right? So in theory, I could put an asterisk there and get rid of that guy. And then I have an array of pointers. Now, can anybody see the problem with this way?
Hard to read.
It is a little bit harder to read. In this case, I don't actually have the memory allocated for both of them. So my next step between lines 35 and 36 would be to allocate some memory to store those. Because I didn't give it a size, I didn't know how much memory to give it, and that's where arrays come in instead of pointers, because it says, hey, I need at least I need 3 large of pointers. It allocates the memory for you at compile time. So that would be the difference. But again, I could have 2 stars, I could have 1 star, and one of those guys. Doesn't really matter. Just understand that an array and a pointer is about the same thing. Questions there? All right. So if I come back to the top, I'm going to modify that division and come back and give myself a double. That way it works. So now down here at the bottom, I'm going to change my line 35 to 4. And now we'll have pfunc2 be a 3. And so, I'm going to declare one more double. Double next equals 0.0. Let me give that a better name. Let's call that denominator. Denominator equals 0.0. And then we'll do pfunc2 3 open parentheses, and we'll pass it first, and then denominator. So we'll try that, see what that does for us. Hopefully it'll work wonders. Don't have any compile time errors, so that works out well for us. Start without debugging, and I got a sum difference product. Press any key to continue. How come I didn't get my division coming out of there? Didn't print it, right? We ran it, didn't print it. So again, let me come up here and cut and paste lines 32 to 34. Paste those in there. And this time we're going to call pump 2, 3. And now we'll pass in the denominator. Start without debugging. And we can see we got product is 1 dot # INF. Is that what we expected?
No.
How come? Say again?
You can't divide by 0.
Well, I'm actually trying to divide by 0 here. I'm taking 0 here, passing it as the second item. If I go up here and look, I've got 1 divided by 2. Well, if 2 is 0, what's any number divided by 0? Well, kind of undefined there, right? So whatever the system wants to work out. In the last case, it gave us 1 # INF. We've got some trouble here. So one thing I can do here is I can use what's called try and catch statements, or exceptions. Because this is an exceptional item here. What do I do whenever I try to divide by 0? What should my answer be? Well, one common thing to do is say, okay, I'm going to put an if statement in here. I'm going to say if it's 2, if 2 is equal to 0, I want to do something. So what should I do if 2 is equal to 0? What number should I return?
0.
Want to return 0? So that's a way to deal with this problem. So now if I go ahead and run it, start without debugging, pops up as, hey, the product is 0. Is that true? Kinda, right? Well, I mean, it's not legal, but this function has to return something that's supposed to be the answer. Well, this is what we call an exceptional situation. I'm supposed to return a solution. I don't have one to give you, but I got to give you a return value. So this is where exceptions come in. Exceptions say, hey, I've hit this exceptional situation that I can't deal with myself. And I don't want to give you back a bad answer, because any number divided by 0 isn't 0. And I can't give you a number back that would make it true. So now we're going to do what's called an exception. So now instead of returning 0, I'm going to throw an exception. So to do that, I'm going to type the word throw, T-H-R-O-W, followed by what you'd like to throw. So let's say in this case, I'm going to throw divided by 0. Don't know how to do that. So how about that? So in that case, I go, hey, if I'm trying to divide this guy by 0, I don't know what to do, but I know I can't handle it. In my little area here, I can't recover, so I'm going to throw this guy. Now let's see what it does. Now I get, oh, hey, here we go. I got a debug error, and now I get all this jibber jabber here of problems. Abort's been called. Well, what's the problem here? Well, just like in baseball, when somebody throws a ball, it's really good if somebody on the other side catches it. Right? So we threw an exception, but nobody was there to catch it, so it bubbles all the way up to the system. The system goes, nobody else caught it, I don't know what to do with it, and you get this runtime error. Because again, this is at runtime. It compiles fine, but at runtime we have an issue. So, in order to catch something that was thrown, it has to be done in what's called a try block. So I'm going to hit abort here, close down. So we did this throw. I've got to encapsulate that in a try. So I'm going to come down here to my main, And I'm going to, in here, I'm going to do a try. And I'm going to say, hey, I'm going to try out the following statement and see if it works. So in this case, I do the try, put that into a try. I go ahead and do a start debugging. There are build errors. Now it doesn't even build. What's the build error? The build error says, hey, you have a try, but you didn't catch anything. You're like, you know, you're right. If I'm going to do a try, I might as well catch something. So in this case, what would I like to catch? Well, after your try block, you've got to open and close curly brace. That's where I put my keyword catch. And catch says, here's what I'd like to go ahead and catch onto. So in this case, let's catch a constant character pointer message. And then I need another open and close item here. So now this guy says, hey, try and do this, and if something's thrown, catch it if it's being thrown a character pointer. Okay, that sounds all right. So I'm going to do a cout statement and say I got a message. So in this case, I'm trying to do this operation, and if it doesn't succeed, I'm going to try and catch the following. In this case, I'm going to catch a character string, and then once I do catch it, I'm going to try and print it out. So let's see what that does. Of course, I build. Now it builds fine. I go ahead and run it, and now it says, hey, wait a minute. I threw this guy, and nobody caught it. And I go, well, I tried to catch it. What was the problem? So I can hit abort here, go back in, come up. Here's my catch. I'm going to come right back up here and see what it is I threw. Now, what you throw has to exactly match what you're trying to catch. So I have to identify what it is here that's being thrown. In this case, I'm throwing some sort of character string, and I got to figure out what it's actually throwing. So before I debug this guy, I'm going to comment it out, and I'm going to throw something that I know we can catch easily. I'm going to throw a number. Let's try that. Because maybe I don't quite know right now how to catch that character string. So I'm going to throw it a number. I can throw anything I want. Let's throw a number. So now what happens if I actually run it? Same problem because I didn't try to catch the number. I'm only trying to catch this constant character pointer. So the nice thing about the try-catch blocks is I can put as many catches as I'd like. So I can put in another catch, but this time I can say I'd like to catch a double. Oops. And this time I got a double of number. So in that case, let's see if I can catch a number. So let's see how that goes. See if we're close. Again, build it. It built successfully, so that compile time was good. Still get a problem. So how come I cannot catch this guy?
Because you don't have it in a try-catch.
Huh?
You don't have it in a try-catch.
Because I have it embedded down there, but it's not inside the function. So this is, huh?
Line 44.
Oh, you're right. Yep. So, in order to catch this guy that's failing, and not that guy, what I would do to find that out is I would come up here to my line 39, and I would turn on my debug statement, and then I would run it with debugging. Let's see where this guy's happening at. Because let's say I wasn't able to catch what line it was on. Now it runs. I'm on that line. I say, where's my next button? step over, step over, step over, step over, step over, step over. It happened. Well, I hadn't quite gotten to my try block yet. Hit break. I'm sitting right there. So I can tell that, hey, I need to move this guy into a try block. So if I go ahead and hit stop debugging, come back and try it again. This time I'll move this guy up in there. Build it again. And start without debugging. Whew. Alright, so there I got a double of 0. Now, the assumption is that this guy threw an exception. It stops executing on line 17 and starts rolling back up through the call stack. It goes from division up to whoever called division. In this case, it was called on line 45. At this point, this never executes because this guy had an exception that was thrown. It stops and breaks out. It says, oh, here's a try. Let me go down and see who can catch me. Here's a guy and here's a guy. Does what's being thrown match what's in these parentheses? In this case, it was a no. Is what's being thrown in this parenthesis? In this case, it was a yes. It executes this statement and then comes down here to line 58 and continues to execute. So let me throw in one more cout statement just so we can verify that that's the behavior. And I'll just put at the end. Come on, fingers. So in this case, I'm now at the end. So let's verify that works. Go ahead and run that guy again. So as you can see now, I got a double of 0. I'm at the end, and it prints out the next key. So now it's actually catching our guy and responding to it. Now, when you grab a catch and you handle it, you're saying that I have now got the system back in a steady state to continue after this. If you catch this and you can't deal with it, you need to throw it again. So in this case, let's say I couldn't deal with that, but I caught it. I would then do another throw and let somebody above me try and catch it. And if nobody above me can catch that, the program then goes into the abort status and the guy stops. So there are your tries and your catches. So again, if it happens on line 45, nothing else executes, it jumps out of that try, tries the first one, tries the second one. If it doesn't find any there, it goes up to the next guy in the call stack. If it is able to grab it, it handles it. If it can't handle it, you have to throw it again to send it back up. So now we expect this time to see this printout followed by the screen that says abort. I run it, and there we go. It says I got a double of 0, but then it still threw it higher because it couldn't grab it. Does that make sense? So that's what they were talking about when they said tries and catches. So one more thing that I'll do is I'm going to come up here, and let's say I didn't want to throw that string. I didn't want to throw that double. I want to throw an integer. So in this case, I'm now throwing an integer. What do we expect to happen? If I come down here to my catches, I've got two options. I can catch a string. I can catch a double. Do I have the option to catch an integer? Nope. So I expect to get a problem from the executable, right? Run that guy, and there's my problem. So what I can do is I can say, you know what? Catch anything else. If there's anything that runs out there, catch that guy. And that's where the 3 ellipses come in. To say, okay, here's my catch-all. If it wasn't one of those other guys, if there was any exception thrown, just catch it and let's deal with it. So in this case, I can see I caught something. Now, as you can see in this case, in these other two catch statements, I was able to use what was passed and print it out. Well, now, because I'm saying, hey, catch whatever's coming, because I don't know what it is, I can't grab any information on what's being thrown. All I know is an exception was thrown, and I think I can recover. So in this case, I go ahead and hit start without debugging, and then here we go. I got something. I don't know what it was, but again, once I caught it, I went to the end, and then continued my program, so my program didn't crash. I was able to do a little bit of recovery there. So if I needed to do things like close down files, disconnect from databases, save the current state, I could do that by, hey, I don't know what happened, but I'm going to recover what I can and gracefully exit. That's a great example of using a throw, try, and catch.
So this is actually what generates your error messages when Windows breaks.
Yep, some exception happened. Whether the system threw an exception because you went out of bounds, or the program itself threw an exception, if nobody's there to catch it, it just bubbles all the way up until, poof, I've got a seg fault. And then here's one of the key ones right here, is that 3 ellipses. It doesn't turn blue, but it's still I call it a key word, but it is a key indicator to C++ that 3 dots or 3 ellipses is your catch-all. So that's kind of like the default statements inside of a switch. If it didn't match anything else, catch it now. And if I wanted to, as a bad programming practice, I could comment all these out and just catch anything, but then I don't really know what happened, so I don't really know how to recover. So that's kind of a poor programming practice to do it that way. So, questions there? I'm going to take that bad programming practice back out. Yes, sir?
Yeah, mine's reading that something got corrupted.
Okay.
Like, it prints out everything, but then, like, the big board screen prints out and has something that, like, is corrupted.
Okay.
Yeah, let me just pull it.
Yeah, go ahead and run it. I'll look at it real quick.
Probably your array definition.
It says stack around the variable pfunc2 was corrupted. So go look at your pfunc2 definition. I don't think after it happened we tried to do any changing to it. No, it's okay to me. Yeah, but again, once you have that, once you start trying to divide by 0, if you don't catch it, you are messing with some memory. So go check that division statement. Make sure you're doing that throw before you do the division.
Okay.
All right, so there's an example of both function pointers, tries, and catch blocks, and how to do that fancy stuff. The last thing the book talked about in there was using, there's a special kind of throw that happens when you try to allocate memory. So what I'm going to do here is I'm going to go up here and I'm going to change line 44 to be a 10. That way we no longer do any throws because now we should have a good value. And I'm going to come down here to right before at the end. And I'm going to try to do some dynamic memory here. So to do that, I just need a pointer. So this is a pointer to an integer. And I'll use the new block, new integers. And how many do I want? Let's do a lot. See if that works. Of course, that's giving me a problem because it goes, hey, I know that I can't get a number for you that big. That's kind of crazy. I'll highlight my little cursor over there. It tells me, hey, that's going to be way too big. I can catch that right now and tell you you're going to have a problem. So what I'm going to do is I'm going to kind of trick the system a little bit. Let's do int my size. and have that equal to a large number. And then in here, let's do my size. So now, even though I use the same number, now it can't quite tell that it's going to go out of bounds. And let's see what that looks like. So again, I'm trying to create a new integer. It's going to be, let's see, 1, 2, about the size of the national debt. Almost there. Let's see if I can get that much memory. So I go ahead and hit start without debugging. It tries, and boom. And it says right here, invalid allocation size. You've gone too much. And you go, okay, well, I'd like to kind of know that before it happens. So what I'll do is I'll go ahead and, what would be the thing that we just learned to do? Try catch, right? So I'll go and throw that inside of a try catch. So try catch. Now, what are we going to catch? Failure, right? So what they've done is they've actually declared a bad alloc exception on the system because that's what they're going to throw to you. So I'm going to come up here to the top, and underneath IOStream, I'm going to include new, and then using std bad alloc. And bad alloc is the exception it's going to throw when that happens. So now in here, if I catch bad alloc, too big. So in this case, if I did try to do that guy and it was too big, now I can actually recover. You go, okay, I can't get one that big. What are we going to do about it? So in here we could make p integer either another size, do something different, whatever we'd like. But in this case, we're saying I can actually catch that as an exception and then go ahead and try and recover, which means it was too big. So again here, if I do a build, start without debugging. No. What are my errors? Yeah, I know that one. Let's see. That should be passed in by address. So that's probably a function call. Try that one more time. There we go. So in that case, we had an invalid allocation size, but I wasn't able to catch that guy. So how do I catch that guy? Plot thickens, right? Did I do it in the right spot? Am I trying it in the right spot? So one way to check that would be, let's say I just make that ellipses and see if I can just catch something. Start without debugging. It pops up. Got that guy going again. So it's not that I'm in the wrong spot. The problem is how it's happening. So again, hit abort, come back in, and say, man, this guy here should be doing this try. I should be able to get that catch out of there. This guy should catch anything. Why am I still not getting it? Anybody got any ideas?
Is that larger than an integer hold for the my size?
Yeah. It's actually, your problem is actually coming from this line. Anybody else see that? So let me go ahead and run it again. So the problem is actually with this one. I'm supposed to get, the largest I can get is 1, 2, looks to be about 4 billion. And I believe I tried to put in there 10 billion. So even though I had this try catch, I thought, man, I'm going to catch this guy right here. the problem was actually a line above. So let's say I did something genius, and I said, all right, let me move this guy around, put that inside the try, see if that catches it, and boom. Now it's broken.
I mean, the program just not letting you get past that point.
Huh?
The program just not letting you get past that inside.
Nope.
It just blows up right when it gets there.
Yep. Any ideas?
Take off a zero.
Huh? Take off 0? All right, take off a couple, see what happens. Oops. So now I took off the 0, but again, that is still too large for an integer. However, now I'm getting too big. And too big is coming from where? Right here. So, everybody see that? Makes sense? Is that better than the one page in the book? Yep.
Okay, no, so if it was still too big for size, how can you just? That's what I'm not getting.
Huh?
Okay, I was trying to think.
Why didn't we catch it when we were assigning the value to the integer?
Because it has to do with storage in the background. It's actually going around this try block and throwing it from inside and stopping it inside. Because it doesn't bubble up, it stops and exits. And that's the problem. That's Visual Studio trying to look out for you and go, I can't do this, I quit. And I think we'll see how to do an exit here on this next example. So, any questions here? Good? Alright, there's just some examples of tries and catches. Save that guy in there. Alright, so the next thing we'll do is we'll try to do this calculator that they did in the book. And we'll try to make it a little more understandable. So, I'll go ahead and start a new project. So I'll close this one down. Let's see, add new project, and this will be a console application. This will be a calculator. There you go. Next, just give me an empty project. I get stuff. Finish. All right, so there's our calculator. Close him down, and now we'll do add a new item. This will be a CPP file, and we'll call it something genius like calculator. Genius. Alright, so here's our calculator file. So what we like to do is we like to make a command line calculator. So, let's say on the command line, I gave you 2 plus 3 times 4 minus 7. We'd like to find a solution to that. So we want to be able to pass on the command line, here's what we have, and then come up with the actual solution to that. So, where do we start? Anybody got any ideas?
Get line work.
Huh?
Get line.
Get line, right? So if I use get line, where does that go? Goes into a string, right? Or some sort of character pointer. So, if I put this into a character pointer, looks something like that. When I read it into a character pointer, what's that at the very end? /0, right? That null terminator. So I got that at the end. So I got 2 plus 3 times 4 minus 7 with a null character hiding at the end. And how do I do that? I do a get line, right? So I should be able to do a cn.getLine. Pull that guy in. So now that I have that, what do I do with it? I know, right? So if we go back to math class, we got these orders of precedence, right? So let's just start out with something simple. Let's use pluses, minus, multiplication, and divisions. So if I had those, which ones take priority? Right. So these two, and then those two, right? So how would I do the math here?
3 times 4.
I would put these two together, end up with somewhere close to 12. And then I would put these two together, end up somewhere around 14. Put those together, end up somewhere around, hopefully 7, right? So we want to implement that. So the first thing I need to do is I need to break up the line into what we're trying to get. So what are my options? Well, I've got either operators or I have numbers. Do I have any other options? The only other thing I have in there is probably spaces. Right? I could have some spaces in there. So I could have spaces. I could have more than one space. Maybe I got some at the end. Never know. So those are the things that I need to take care of. So the first thing we're going to do is get rid of the spaces. If I don't get rid of the spaces up front, I got to deal with it every time I go try to pull out the next operator. So the first thing I'll do is remove spaces. So once I remove those spaces out of there, what's the next thing I need to do? Huh?
Take the first number.
Grab the first number. Then what do I do?
Get the operator.
Grab the next operator. Then what do I do?
Number.
Grab another number, right? All right. Then what do I do? Grab the next operator, right? All right. So if I repeat that sequence, what's going to happen?
You're eventually going to hit /0.
What happens when it hits the /0?
You stop.
I'm done, right? Now, if I do it in this order, I'm not going to have my order of precedence. So I'm going to grab a number, grab an operator, grab a number, I get 5. Grab an operator, grab a number, I get 20. Operator, number, I get 13. 13, I was really hoping for 7. So I got to change my logic up a little bit, and I got to break it down into higher orders and lower orders, right? So now, if I had another color,
So do you start by going until you get the first asterisk or a division symbol?
so I need to divide it based on precedence. So I'm going to divide it up by going, here's a block, here's a block, here's a block. And then I deal with this expression first, because it has a higher order of precedence. Then I deal with this expression. Then I deal with that expression. So, let's give it a shot. So the first thing I want to be able to do is grab it, read it in, right? So, come in here. Let me scroll in. Of course, the first thing I want to do is include something. What is it? IOStream. IOStream. If I could spell. And then, of course, I've got this int main that I always got to start with, because that's where a console program starts by default, with some return 0. And so in this case, it's going to be called a calculator. So I'm going to be nice and say, welcome to the calculator. Enter your expression. So, how do I get it? Well, I have to do that cn.getLine, right? So let's be naive here. I do cn.getLine. And it tells me, here's the 2 things you need to make this work. You need a character pointer, as well as how many you're able to read in. All right. So where am I going to put it? You need to declare something, right? Got to have something before I can use it. So let's do it the old-fashioned way. Character pointer, character buffer, and let's say 80 right now is my limit. Well, just to be a little bit more expressive, I'm going to make that a variable. So now here I'll put max. Alright. So now in here, I can read in the buffer, followed by max. Oops. So now I should be able to read that line in. So before I get too far, I'm going to put in a little statement to make sure that I'm getting what it is that I'm receiving what it is that you're giving. So I'm just going to do a cout, and I'm going to print out buffer, just to make sure we're on track. So start with that debugging, pops up and runs, and now I get that stuff. Is that what I expected? No, right? So, over here in my Solution Explorer here, because I've got two guys open, this guy is bolded, which means he's the main guy that's going to run when I hit go. So I just got to tell this Visual Studio that, you know what, from now on, pick the other guy. He's going to be the guy in charge. And let me remember how to do that. Set as startup. So now if I look at it, he's got the bullet line. He doesn't. So now if I go ahead and hit debug, start with that debugging, there's the one that I was looking for. It says, welcome to the calculator. Enter your expression. And let's say we'll take 2 plus 3 times 4, whoops, times 4 plus, or minus 7. So I got back what I gave it, 2 plus 3 times 4 minus 7. So I know my read's working. Okay. So, first thing I want to do is I want to remove the spaces. So how do we remove the spaces? So the nice way to look at it is I draw it up just like I have it up here on the board. That's kind of helpful. So 2, 3 plus times 4 minus 7. If you look at this as an array of items, plus the /0 at the end, look at it something like this. So what I'd like to do is get rid of all these spaces. So how can I get rid of the spaces? I'm up for suggestions.
Throw
What?
characters.
How about I start looking through my list here, and when I get to a space, take what's on the right and move it over. Let's just move everything over. I know I've got enough space there, so once I get to the plus, move it over. Once I get to the 3, move it over. Move that one over. Move that one over. Move that one over. That one over. That one over. Make sense? Pretty easy, right? Well, so I need to know where I am and where I am in my new string. So how about I have a guy called old and a guy called next. And we'll have both of them start at the beginning. And I'll have this old guy start working through to find the next one. And this guy will stay right here until I find the next guy to move over. So we're just going to iterate through this guy to find it. So I would say, okay, so the first time through, they both are going to this one. I move my old guy over to 1. This is a guy we want to keep, so I move my next guy over to 1. Now they're both on a space. Do I want to keep spaces? Nope. So I'm going to keep this next guy right where we're at, and I'm going to move old 1 over until it's not a space. So I move him over to be a 2. At index 2, I'm going to write them up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14. So at index 2, is that guy space? Nope. I want him. So move him over to where next 1 is. So now he's a 1, and I increment my next guy to the next space. And then I move old 2 over to 3. Is it a space? It is. Do I want it? Nope. Go to the next one. Is 4 space? I want it. Where do I put it? In slot 2. Go to the next one. And I keep going until when? Until I get to the null character, right? Too easy. So, let's type it up. So, doing that same concept, come right here at the top, and I'll do a void, and I believe the book called it eat spaces, whatever you want to call it, and it takes a character pointer. So now in eat spaces, what I want to do, well, I need to have a old guy and a new guy. So I can do an int old, and what do I call the other one? Next. So now, what do I want to do? Well, I want to keep going in a loop until I'm going to keep doing something until I don't equal that /0. So, what do we want to do here? Well, what I'm going to do is I'm going to take my string str and add to it where I'm currently at in the old guy and set that equal to where I am in the new guy, and then increment that one. So I'm going to wrap that in parentheses. So here's a little clever way of incrementing through a character pointer by taking the next guy and moving it over. And then, inside of there, if the guy is a space, we're going to increment our old pointer. So here, if str plus I does not equal a space, it's going to be old. Come on. So in this case, we're just going to keep going. So if you gave me some spaces, we're going to try to ignore them. And then when I'm done, just return. So again, I come down here to eat spaces, and now I'm going to call eat spaces, pass it in buffer, and then let's print it out again and make sure we're getting the results we're looking for. Because again, I want to do this in baby steps, make sure I got one thing fixed before I go on to the next one. And I'll try and run it. Enter your expression, 2 plus 3 times 4 times 4 minus 7. And the top line here is where I reviewed it back, and the bottom line here is what I got after we ate those spaces. Shrunk it down. So let's say I did something crazy here on line 6, and I use the equality operator instead of the assignment operator. What would happen then? Start it again. And I got 2 plus 3 times 4 minus 7. I got 2 plus 3 times 4 minus 7. Nothing happened there, right? Well, why not? Well, again, I went through my string, and I went through the whole string, and I just compared these two if they were equal or not. While true or false does not equal a null character, increment my old guy. And that just continues. I didn't actually do any moving. If I wanted to find that out, I could turn on the debugger here in line 5, run it in debug mode, and then walk through what the code's doing to understand what it is it's doing. But I know the problem here would be I use the assignment and not the equality. So again, get rid of the equality, back to the assignment. Now if I go and run it, I should get a good result. And again, 2 plus 3 times 4 minus 7. And there, I took those spaces and chunked them down. Now the book, or the C language, really likes this syntax because it's very fast. Well, we can write this in a different way that might not make it look so crazy. I can do that by using a array syntax instead of a pointer syntax. So I'm going to do the same thing here, but I'm going to do it as an array. Void eat spaces 2. So in this case, just give me, I'm going to treat it the exact same way, except now I'm just going to use this pointer notation to make it a little more clear. So, again, I still need the same options. But now here's where this while is going to look a little bit different. So while str old equals str next plus plus. So while those guys, we do that assignment, and what I put inside of old, too many, does not equal that new line character. I have enough parentheses there. There we go. If str old does not equal a space, so there's the exact same thing using an array notation instead of a pointer notation. It does the same thing. This code here is probably 2 or 3 milliseconds slower than this pointer notation. Now, as those 2 or 3 milliseconds save you on some clarity, you'll want to go this way. If everybody on your coding team can understand this and not make any pointer arithmetic errors, this is just fine. But again, anything I do with an array, I can do the same thing with a pointer. So these actually do the exact same thing. It's whichever one you like to see better and work with more. Now I know when you have all these parentheses and asterisks, it can get a little confusing. So if you don't like doing it that way, just use a plain old array syntax and do the exact same thing. Questions there? All right, so what's the next piece we need to do? So now I've got this guy bunched down. So now I no longer have these spaces anymore. I got rid of those guys. So now they're all right next to each other. So now the next thing to do is break it down into these expressions. So, how can I do that? Well, pretty much, what is it that I'm looking for?
Constantly tell the program that which are operators and which are numbers.
Yeah. All right, so we'll do that with what's called expressions, is the way that they did it in the book. So, again, I'm going to come up here, and I'm going to do expressions. So to do that, this is going to return a double. Expressions. Now, you can do it the array way, or you can do it the pointer way. Doesn't matter. An array is a pointer. They do the same thing. So if you like the pointer syntax better, use it. If you like the array syntax better, use it. So we're going to start this guy with a value of 0. Because of course that's what we're going to start with. We're going to assume we have 0 and then work our way through. I also got to identify which step I'm on, and I'll do that with this index value. So this index value is this pointer that tells me which expression I'm currently on. So we're going to start out being at the first one, or the 0, and then work our way through it. So now what I'd like to do is I'd like to get the next term out of there. And each of these brackets is what we're going to call a term. So, to keep this working, I'm just going to call a function that doesn't exist yet, and then come back to it. So, first off, I'm going to say value equals this term that I have, and I'm going to get that by passing in the string, followed by what index I'm on. And that should give me my first term. And then, once I grab the first term out of there, what's next? Well, it better be an operator, right? That's what we're shooting for. If not, we have a problem. So, I'm going to put this in a loop, because we're going to keep going until the end. And that's where this guy comes in. Oops. I've got a for loop with 2 semicolons, which means you're going to keep going until I tell you to stop somewhere inside. So now we're going to say switch. I'm hoping that the next index that I'm on, past the one I'm at, is an operator. So, I can use the asterisk notation to do the pointers. So that would be a way. Or I'll put out here in parentheses, str index. Use whichever one that makes the best sense to you. So in this case, what are my options? Well, the way we broke it up here, I could have either a plus, a minus, or a null character. That's the way we've got this guy broken down. So let's add in those options. So, case, if you are a /0, what do we want to do? Well, if I've got a /0, I've hit the end. So let's go ahead and return the value. That means we're done. We're a winner. Now, I'm going to add a break in there just for consistency. Doesn't need to be in there. I just like to have every case statement have a break. So it's a pet peeve of mine. So the second one here is, my other option could be a plus. Well, what happens if we have a plus? I'll take the value I currently have and add to it what? The term that's on the right. And then, of course, if I do a plus, go ahead and break out of there so we can go again. What's my other option? Subtraction, right? There I'll do a minus equals. So what if I do if it wasn't a /0, a plus, or a minus? What's my other option? Huh? Well, not yet. We said this was going to be an expression. So if it's not a plus, it's not a minus, and it's not a /0, you must have gave me something stupid. So I got to somehow say, okay, what do I do if you gave me something crazy? Well, one way to do that is going to be error occurred. And go ahead and exit immediately. This is what you do when you don't want to deal with exceptions and you just want to exit the whole program. So exit 1 says, go ahead and stop executing now. I'm out. On Thursday, we'll make that an exception. So there's how we're doing our expressions. So we're going through and grabbing the next term. Now, how do I determine if we have a term or not? How do I pull out that next value? Well, I need to write a function for that. So I'm going to scroll to the top. And of course, I have to declare it before I define it. So I'll do it up here at the top. And again, this guy's going to return a double. It's going to be called term. What's it going to accept? That character pointer. And a index. As you can say, in this case, I'm passing it in by reference, because when I move that index pointer, I want the caller to know what got moved. So again, same thing in here. Double value 0. Got to start with something. And then I'm going to do value equals. And what do I want to pull out of this term? Trying to pull out a number, right? Well, it's actually a built-in thing that does that called number. So that guy pulls out a number. What do I want to do once it finds a number on the next one? Well, if I just return, I got to still deal with this special case. So now I need to check, hey, is the next guy following a multiplication or division? If it is, I need to do something with that. So again, here's where we'll check. So before I use a for loop, here I can use a while loop. So just like I did down on line 37, I can do while instead of a for. Doesn't matter which one you do. So again, I can use pointer notation or I can use array notation. Let's say in this case we'll use array notation. str index equals an asterisk. What do I want to do if it's an asterisk? Well, I want to take the value and multiply that by the next number that should be on the other side of it. What's my other option? Else if that index equals a division. I think division is the other way. Yep. Then what do I want to do? Well, then I'm going to slash equal the number. And of course, if I didn't do either one of those, go ahead and break out. And then return the value. So now I'm dealing with multiplication and division inside of this term. So now I deal with addition and subtraction in one area, multiplication and division in the other. And of course I've got a squiggly line. What does squiggly line mean?
Doesn't know what word that function.
Doesn't exist, right? I need an easy way to pull out a number. Well, there's some easy ways to do that inside the standard template library, but we don't have those right now. Those aren't covered to like chapter 8. So now we got to do this the old-fashioned way. and actually make our own number puller. So, to do that, come back up a little bit more, and we'll make another function. What's this one going to be called? Number. What's it going to take? Character and index. So, this guy's supposed to be a number, right? So, let's have a spot to hold my result. So, what's the first thing I should be looking for inside of this string? A digit, right? So, this guy better be a digit. Well, what if it's not? So, I'm going to use this isDigit, str index. So, what do I do if it's not a number? Got a problem, right? I don't know what to do. We'll add some exceptions on Thursday. Exit 1. Again, if you didn't give me a digit, I've got a problem. You messed something up with the input. What if it is a digit? We need to cover that on Thursday because we're out of time. So I'm going to save this just like it is. I'm going to upload this up to D2L. So if you don't like your version you were following along with, you could download this version the next time for class, or you can keep using yours, whichever you like. Any questions?